So there are few important things that we can do using this analysis. The first is that we can understand when these factors fail by looking at the history. So if the disturbance become large, we can possibly find out why they were large and things like that. And we can probably look at a growing phase. So ultimately, I'm going to get two things. I'm going to get a back test, but I'm also going to get a contribution image where I can find out how these are contributing. Okay, so this has to be done by taking into account all peers that you want to use, because you want to believe that all peers have the same explanation of multiple. So if your peer is having high leverage and it is having good multiple, then maybe you want to increase your leverage. If your peer is doing more return on capital, maybe you want to do more return on capital. And to quantify how would that affect your multiple, because a change in multiple reflects a direct change in your valuation. So this is how we will look at here. I'm moving back here and getting more into the different kind of things that we have. So we have to make sure that this true false flow into the system. To do that, we have to bring a framework here. So the framework is not tough, but again, a few things that are changed here because you want to make sure that you copy the right thing. That's one part. Now you have the model and the actual number with you, which you can fit. It's being corrected for what you want to do. So that's how you're going to look at things. Uh, Now when we move ahead from here, you have selection of like 16 parameters, because Excel allows 16 parameters and not more than that. So in case you are looking at different numbers, in case you want to get more numbers, then you can get those numbers as well. Now there are two things here, the difference between NTM and LTM, and the importance of growth in explaining the multiple. So let me see if I have something here. Yeah, here it is. So growth. Now when we look at technology company, the maximum contribution is probably explained by growth. Maybe in defense it's more about the distribution thing and things like that. That's one part. In and the equation that you get is for the whole sector. Uh, the other part that you want to make sure that you get is when you have this regression equation, you can have like more than 100 factors which you can then group, and you can make sure that you use the right group. So you can have a macro group, you can have a return policy group, you can have a leverage group. Now your leverage group would have the debt to EBITDA, the debt to equity, the debt to total asset, and you want to fit in that makes more sense to you. So a lot of permutations required here, and the other part is the NTM versus the LTM numbers. So most of the times the multiple is forward looking, so we would use the NTM number, because even going back into the history, we want to make sure that we have those things accounted for. So this is the contribution. Now for this you have to pull these data for all the companies, get it into Excel and perform the regression. I'll show you an alternative way to do the same in R, and how to change the regressant in R. So that's something that I plan to do in a later thing. Okay, so that was about sectors. Now each sector behave in a different way. You might want to get some custom factors like oil prices when you are doing some oil company, or whatever you think might make sense. You can bring those things inside the system. So if it's an energy company, you can have electricity prices and things like that. So that was about a softer look here into the regression equation.